Hey guys, here is a video on reviewing how to solve quadratic equations. A couple of you in class mentioned that you still felt a little bit uneasy with solving these equations, so hopefully this video will help you gain some confidence with quadratics. So what I've put here are just some guidelines to follow regarding which method to use for solving quadratics. So first thing is we have several methods that we can use. It all depends on the format or the form that it comes in. If you have a quadratic in this form right here, where you've got the three terms ax squared plus bx plus c, or you might see one where part of it is on the other side, like this one, x squared plus 3x equals 5. What I want to emphasize here is it has the three terms. 1, 2, 3. Three terms on that one. 1, 2, 3. Three terms. So when you've got a quadratic in this standard form, you have two choices for your solution. You can either factor it if the problem factors. So you've got to play around with factoring, but factoring will work if the problem factors. If the problem doesn't factor, or even if it does factor, you can always use the quadratic formula to solve quadratic equations in this form. And right here, I've reminded you of that quadratic formula. Be aware that that division is over the entire top part. The negative b plus or minus the square root of b squared minus 4ac. That whole part is in the numerator. All that is divided by 2a. Where do the numbers a, b, and c come from? They come from your first coefficient, that's on x squared, your second coefficient, that's on x, and your third coefficient, or actually it's the third value. There's no variable on that c, on that third value. So to use the quadratic formula, you just need to pop off the value of a, b, and c and plug them into these different positions, and then be real careful in simplifying that. So suppose it's not in the ax squared plus bx plus c format. Suppose it's in this format, where it's missing the middle term, the bx term. If it's missing the bx term, like in this case, I just have ax squared plus c, then we can use the square root method to solve this type of quadratic. Notice again that it may come in a format like x squared minus 6 or 3x squared equals 75. In both of these cases, it's missing that bx term, that middle term. See up here, it's missing the bx term. Again, we can use the square root method. I'll illustrate that in a minute. Or we can always use the quadratic formula to solve a quadratic in this form. That quadratic formula is kind of nice because I can use it for both forms. Let me show you one last form that your quadratic may come in. The last form I want to mention is this form, form C, when you're given the form to be ax squared plus bx, and it's missing the c term. So if we go back up to the top here, the standard form is ax squared plus bx plus c. If your quadratic is missing that last term, that c term, then for these guys, you can always factor them. And for these guys, you can always use the quadratic formula. So those would be your two choices for methods of solution. Okay, so then how about we go and work some problems? So let's take a look at the sheet that I gave you in class and also emailed you. Let's take a look at this sheet for solving quadratic equations. So the first grouping of problems we're asked to solve by factoring. Well, they're asking us to solve by factoring, so we're going to solve by factoring. That means we're going to look at it and get it in the correct form so you can actually factor. So in order to factor, we need to have our equation set equal to 0. And what's nice is this guy's equal 0, that guy, this guy, this guy, and this guy. They're all set equal to 0. Problem is number 3 is not. So in order to factor him, I need to set him equal to 0. So for problem 3, I would need to take over that 40, subtract him so he's on the same side as the other terms. Then I could factor him. So to factor it, I need to have my equation set equal 0. So let me grab a couple of these and factor them for you. Let's look at number 1. X squared minus 64 is a difference of two squares, and differences of two squares will always factor nicely. The x squared will break down into x times x. The 64 breaks into an 8 times an 8. And to get middle terms to cancel, I would need one to be a positive 8, one to be a negative 8. And remember, once it's factored, all you have to do is set each factor to 0. X plus 8 is equal 0, x minus 8 equals 0. A solution of negative 8 and a solution of positive 8. Those would be the two solutions to that quadratic equation. Let's pick another one. How about the one right below it, number 4? I know I'm going to factor it. It doesn't have two terms, it has 3 terms, which means I need to set up my trial and error 2 sets of parentheses to try and factor that. And remember, in factoring, you're trying to figure out what 2 things in front multiply to give you that first term. And the only thing I can multiply to get a 2x squared is a 2x and an x. Okay, now the next thing I have to decide is what 2 things can I multiply to get this last term of a 1? Well, it has to be a 1 and a 1. Now the last part in this factoring is to decide if the numbers I put in will work to give me that middle term 3x. This is the magic part. So 1 times x is a 1x. 2x times 1 is a 2x, and if I added those two guys together, I would get the 3x that I'm looking for. So that means both the one, the first one and the second one would both have to be a positive, so that 1x plus 2x would give me the 3x. Now I've kind of run out of room here, but you know the next step is to take the first factor, set him to 0, and take your second factor and set him equals 0 and solve each of these. Here we'll get a negative 1/2, and here we'll get a negative 1. Let's look at one more to solve by factoring. I'm going to look at problem 6 here. Notice it says I'm going to use factoring, and notice that number 6 only has 2 terms. Number 1 only had 2 terms, and I was able to, because it was a difference of 2 squares, I could factor him into x plus 8, x minus 8. This guy was missing the bx term. Over here, this guy has 2 terms, but he has the bx term. He is missing that last term, the c term. I can factor this. And what's so easy about this is we're going to factor by pulling out the greatest common factor. What's common to these two guys is an x, so I am going to factor out that x. And when I factor out an x from both of those pieces, I'm left with x plus 6. You can always check your work by remultiplying. X times x is x squared. X times 6 is 6x, So I have successfully factored that. So that's an excellent way to check your work. And remember, once it's factored, you can set each one of those factors to 0. So one answer is x equals 0. The other answer is x equals -6. Two answers. Every quadratic has two answers. Now, I would suggest you work on the other ones that I didn't work, practicing on your factoring. The next section on this sheet wants us to practice the method of using square roots. So if we go back over here, the square root method is going to apply when my problem is missing the middle term. It's missing the bx term. When it's missing that term, it might look like one of these two. And we're going to use the method of square rooting to solve this type of equation. So let's see how that method works. Okay, method of square rooting, we are going to do that right here. Okay, so the square root method involves you actually just taking the square root of both sides of an equation. But before you can square root both sides of the equation, you have to have the square term by itself. This x squared needs to stand alone on one side of the equation by himself. So this guy stands alone. This guy does not stand alone. I have to do something with the 4. This x squared does not stand alone. I have to do something with the 7. So I have to have it in the form of x squared equal to something, or I have to have a square on the left equal to something on the right in order to use the square root method. All right, so let me illustrate the square root method. We'll do a couple of these. Let's say x squared equals 64. The square root method says I'm just going to take the square root of both sides of my equation to get my answers. Well, we know the square root of x squared is x, the square root of 64 is 8, and when you take the square root of both sides, you must put in the plus or minus. So we get two answers, x equal +8, x equal -8. You'll probably notice we did that problem earlier, problem number 1, but it was written as x squared minus 64. I could have very easily solved problem 1 by taking the 64 over and square rooting both sides. Okay, let's look at another one. How about problem number 9? I can't solve him until I get the x squared by himself. So I am going to subtract that 7. So I get a -300 minus 7, which is a -307. When I go to take the square root of both sides of this guy, we kind of have an issue because I'm square rooting a negative number. And that's an imaginary number, and we're not dealing with imaginary numbers right now. So this one actually has no real answer. Later on, we'll look for that answer, but right now, there's no real answer. For problem 8, I'd have to get x squared by itself, so I would need to divide both sides by 4 to get me x squared equal 81 over 4. Then I could drop a square root on both sides to solve it. The square root of x squared is x, and the square root of 81 over 4 is the square root of 81 over the square root of 4, so I'd get a plus or minus 9/2. I will stop this video here. I would say you finish it up with problem 10, and then I'm going to do a second video on the rest of these. I hope this is helpful.